This, good day, everyone. This is Orekoya Olusegun Mathematics for Physics Fundamentals on YouTube. Please, before we go into today's exercise, do not forget to share, like, subscribe, and click on notification button to be able to have more of my video. Today, we are going to take a topic under analytical geometry, and the aspect of the analytical geometry we are going to take is a particular subset topic under conic section. I've discussed what conic section is in my other video. Please do make a visit to my other video so that you can understand what conic section is all about. Now, we are going to take an exercise under circle. A circle is a locus of points, an arbitrary point that moves in such a way that its distance from a fixed point called the center of the circle is constant. So now we are going to take an exercise that involves parametric equation of a circle. Now let's look at this particular circle. This is a Cartesian coordinate system. This is the vertical axis and this is the horizontal axis. Let me say the point of intersection of the two axes is 0. Now, let's locate a point C, which is the center of the circle. This particular point C along the x-axis is taken as A, and along the y-axis here, the point is taken as B. So in a nutshell, the point C is described by coordinate AB. Coordinate AB. Remember, standard point P, we normally write x before y, the value for x before we write the value for y. So that's why I'm putting the value along the x-axis as my A and the value along the y-axis as my B. So we summarize this as coordinates. The first value here is known as the abscissa. The second value here is known as the ordinate. The two of them are called coordinates. Now, let's locate an arbitrary point that form part of the circle. Let's say this is the circle now with this center C. This is the full circle with that center C. If I locate an arbitrary point P on the circumference of this circle, this is the value of it along the x-axis is x and y. So this particular point, the location along the x-axis will be x, and the location along the y-axis will be y. So now, if I take the radius of the circle to be r, and I have a right angle triangle, if you look at the height of this right angle triangle, the value of it is changed in y-axis, and the base of this triangle, the value of it is changed along the x-axis. So for the sake of clarity, I'm bringing this triangle out now. So this is the triangle with radius as the hypotenuse of that triangle. This is the right angle triangle. This point P, I put it here as xy, and the center C, I put it here as AB. So now, the change in x-axis, that means x take away A, is taken as x minus A, and the change in y-axis, along the y-axis, is this particular y, which corresponds to y, then this other y, which corresponds to b, that is y take away b. So I write it as y take away b. Now, using what is called Pythagoras theorem, which says that the square of the hypotenuse is the sum of the square of the height of a right angle triangle and the base of the right angle triangle. So I can write my r square now as change in x square plus change in y square, and then the change in x square is what I put here, x minus a. So I have x minus a square plus delta y, this is y minus b, I put it here, y minus b square. So I now have r square. So I can take this r square to the other side of the equation. So I can write it as x minus a square plus y minus b square minus r square, everything equal to 0. What I have here is known as a general circle equation. general circle equation.